Hey there, Mr. Witherow. All right, so today we're gonna find zeros by factoring, solving. All right, the biggest thing that we have to understand is the zero product rule that says that if we multiply two things together, or more than two things, and it's equal to zero, that means one of the things has to be zero, right? Makes sense, right? Zero times anything is zero. So when we factor something, right, and we get that, then that means either this factor is zero or this factor is zero. However we can look at that. And whatever this is, this could be a greatest common factor. It could be two factors if we've got a trinomial or a perfect square or something like that, difference of squares that we can factor out two things, right? It could be three things, however many things it is. So let's take a look at some examples here. We do have to do a little bit of math before we get to this part. And so we have to make sure that we set everything equal to zero. We may have to do some crazy factoring, right? And all that good stuff. So we gotta set this side equal to zero. So that means that this becomes this, right? So we've got four terms here. So that's grouping, factor by grouping. So we're gonna section off right here. So what's the greatest common factor between these two things? Looks like it's an x squared. And we're left with x plus 7 left. And then we have a greatest common factor between these two terms, which looks like it's to be a -9. And we're left with x plus 7 is equal to 0. We now take the two things that are not alike and put them to a, and then we bring down the thing that is alike and equals 0. So again, we've factored three times here. You took a greatest common factor out of the first two terms, you took a greatest common factor out of the second two terms, then you took a greatest common factor of these two terms, which happens to be the x plus 7, and then you're left with x squared minus 9 times x plus 7. So you're thinking that we're done, but we're not. Remember, we get to go to this thing called factor completely. So if we factor completely means that we have to make sure that inside each one of these parentheses, we can't factor it again. Well, lo and behold, this one right here is a difference of squares. So that means now this one gets broken down to x minus 3, x plus 3, because what did we multiply to get -9? -3 times 3, that adds up to that middle term of 0, which is that. This one just comes down, equals 0. So now we have three factors, which means one of these three factors has to be 0 for it all to be multiplied together to get 0, which then we just set them all equal to 0. So we say x minus 3 equals 0, x plus 3 equals 0, x plus 7 equals 0. So that means that x can be 3, x can be -3, and x can be -7. Those are our choices. So if x is any one of those three numbers, then this is 0. That's what it means. All right? So the biggest thing here is that now that we are factoring completely, we always have to ask ourselves, is there another, can I factor it again? Can I take that factor and factor it again, right? So be prepared for that, because that is something that you're gonna have to remember how to do. All righty? Okay. The other thing that we have to do here is remember the fact that we have difference of our cubes here. So this one right here, we can take a greatest common factor of 3x out, and we're left with x to the third minus 8 is equal to 0. All right? So now again, if we factor completely, and I'm not 100% prepared, my fault. I should have had, where's my sheet from the other day? Hold on. Oh, there it is. Okay. Hold on, I'm still there. I just want to make sure that we have all of this together here. Well, at least I think I had it. Where in the heck did I put that? Oh, here it is. Okay, so this is the cubes, right? Sorry about that, folks. So this is a difference of cubes. So if you have this sheet from earlier, then you can have, here's our pattern here. So we can do this pattern. So I'm gonna set it to the side here, and this says we bring down the 3x, then we have x minus 2, and then we have x squared plus 2x plus 4 equals 0. All right, so remember that when we have a cube, difference of cubes here is the fact that we have to remember that we have to write this differently, right? So this becomes x to the third minus 2 to the third, right? That's what this is. That means now that we have a is x and b is 2. So when you have your little difference of cubes here handy, then you can substitute that stuff in. A is x, so every time I see an A, I'm putting an x, and every time I see a B, I'm putting a 2. All right? So then what happens now is that then you have to set them all equal to 0, right? Which you're like, oh my goodness. And yes, it is oh my goodness. You're gonna have to set this equal to 0. You're gonna set this equal to 0. And you have to set this equal to 0. And so these are easy. This is 0 because 3 times 0 is 0. This one is x equals 2, right? But then what do we do with this one? Well, this one we have to remember the quadratic formula, right? Quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula, because there aren't any two numbers that we can multiply to get 4 that add up to positive 2. So now we step in this world of quadratic formula, which means that we may not get, all of these wonderful, fun little numbers like 0 and 2. We're going to get a little bit more challenging numbers, right? So remember that the a in this part is 1. So this is a is 1, b is 2, and c is 4. So then we take this information and we plug it in. So the opposite of b, so that's the opposite of 2, plus or minus the square root of b squared minus 4 times 1 times 4 all over 2 times a, which is 1. All right? So now I'm going to go ahead and knock this off, and I'm going to bring this down here. So this is opposite of b, which is negative 2, plus or minus the square root of, well, what's 4, right? 4 minus 16. So again, if you have your calculator here, and you put that into your calculator, 2 squared minus 4 times 1 times 4, you're going to get negative 12. Oh boy, negative 12 over 2. Which then means that you're going to have an imaginary number here. We have to break this down. So this is negative 2 plus or minus. We know that there's an I in there. So folks, remember that the square root of negative 12 is really the square root of negative 1 times the square root of 4 times the square root of 3. And then the square root of 4 is 2, the square root of negative 1 is I, and the square root of 3 is 3. So that's what this is. So we take this and we plug that in here, 2i square roots of 3 all over 2. And then we can factor out a 2 on top, right? And we would get negative 1 plus or minus I square roots of 3 all over 2, which means then we can cancel the 2 out, and we're left with negative 1 plus or minus I square roots of 3. That's your other factor. Yeah, I'm talking math. Again, it's awesome. We just start putting things together. And we remember this quadratic formula from a long time ago, and we put it aside. And then the great thing about math is that we bring it back, right? And so if you understand this part, This is the harder part. We can always put numbers in, but then can we actually do the calculations and remember how to do the calculations? So these are the real zeros and these are the imaginary zeros, all right? And sometimes that's what you're gonna get. So give it a shot. Sometimes some teachers out there will accept you to get to at least here, all right? Most teachers will expect you to get to here, but then we would always love to see if you can always get down to the final product down here, all right? So just be aware the other two problems that we could do are sitting right there. It's the same type of thing. Make sure that you're looking to do all the factoring that you can. Remember that you have to set it equal to 0. So we would move this one over. So put it in standard form, all right? Put it in standard form. Take out a greatest common factor, which looks like it would be 2x. So we're left with x squared plus 6x plus 9 is equal to 0. Now this is a perfect square. We multiplied 9 to get by 3. 3 times 3 gives us 9, and 3 plus 3 gives us 6. So this one is an easier one, quote unquote easier one, because this is x plus 3, and some people will put the quantity squared. Some people will put it twice. All right. So then we said, now we only have to do this one once. It's the same thing. So this is 2x equals 0, which means that x is 0. Whenever you have an x sitting out here by itself, that means x is 0. And then x plus 3 equals 0, which would be x equals -3. So then there's your two answers. All right? So 3 different problems, right? Thinking that you have to do it completely before you do anything. Set it equal to 0, take out a greatest common factor, and go from there. All right? This one is by far the most challenging one. Just be prepared for it. Sometimes you're going to be asked to do something like that. All righty? Okay, keep having fun with math.